Hi. Let's go through all the bike parameters. I'll bring one bike to my level. I'm going to lock my details panel so that when I deselect my bike, the details remain. The first category is the bike setup. Here I have the bike scale. You can scale your bike compared to the meshes you have imported. You can also keyframe this scale parameter in your sequencer. Next is the trace ground. If it's on, the wheels will always stick to the ground. If I turn this off, I can move my bike freely. To see the next two parameters better, let's first turn on the trace debug. I'll select the first option. You can see how the bike and the wheels trace downwards until they hit something and are located there. The radius of these trace spheres is equal to the radius of the wheels, but here you can modify their radius with these parameters. You can see how these trace spheres are being resized with these correction parameters. You can do a wheelie or a hard brake with these. The next one is the editor update toggle. So, as you know, this blueprint works in the editor and does not need simulating, and this is the toggle for this feature. If I turn it off, the bike does not react to anything unless I hit the simulate button. Then there's this tick FPS that sets how often the blueprint should refresh in the editor. If I set it to 10, you can see how the bike's movement is stepping. This is only for visuals, and as soon as you hit play or render, the editor event is off the cycle. The last one in this category is visibility. When turned off, the bike will be invisible and the billboard will be visible, so you can easily spot your hidden bike. This parameter is keyframeable in the sequencer, and it also affects your render. Let me open the sequencer so you can see which parameters are keyframeable. All the parameters with this icon next to them are keyframeable and accessible in the sequencer. The next category is the suspension. The suspension stiffness sets how fast the bike reacts to shocks. I'll set it to 0, and you can see how slow the bike adjusts the pitch to the wheel locations. 9.9 is the maximum. And 10 is instant. Let's experiment with a plane. Next is body leaning. When you change steering or drifting, the body leans accordingly, and you can control the leaning amount with this parameter. It can also be negative if you need it. The next two are body roll and body pitch. You can keyframe body pitch to exaggerate acceleration or braking. And body roll can be added on turns and corners for some MotoGP style bike riding. The next category is the riding. Let me add a path here quickly. The path drop-down shows all the compatible paths to attach your bike to them. Let's animate the bike on this path by keyframing the distance traveled. The next parameter is the response speed. It sets how fast the bike aligns rotation to the path. The minimum is 1, and the alignment in this case will be slow. The 9.9 is the fastest. And the 10 is instant. By the way, the movement you're seeing is not the alignment delay. The alignment is instant. It's the steering delay. Since Unreal splines can get choppy at curves, you can use this response speed parameter to smoothen the bike rotation. I prefer lower amounts, but it is completely up to you. The next one is the path side offset. With this parameter, you can offset your bike sideways from the path. The amount is in centimeters. Following that, there's a detach from the path toggle, and as long as it's on, the bike cannot attach to any path. You can keyframe this in your sequence, but to do that, you need to also keyframe the path parameter so the bike can find its path. Let me show you how. First, I'll select my path and click on this plus icon to keyframe my path. You can see the path track is created here. And then I'll add this detached track. When the track is red, the bike is not detached. When it's green, the bike is detached. You already know what the distance traveled parameter is. This is the main parameter to move your bike on the path. If the distance exceeds the path length, the bike will go to the start and continue from there. The next one is the distance offset. This works like an additive to the distance traveled track. You can quickly modify and correct the location of the bike on the path without touching the distance traveled track. You can also locally boost the movement of the bike using this parameter. The next two are drift and steering. As you can see, the steering does not work. That's because the bike is attached to a path, and this auto steering on path is on. In this case, the steering of the bike will be automatic based on the path shape. If I turn this auto steering off, I can then modify the steering and keyframe my custom steering. We have burnouts for the front and the rear. These can have a negative amount for reversed rotation if you want. Just keep in mind that the speed of these can be very different in the editor and the render, because in the editor, they depend on the editor tick FPS, and in render, they depend on render FPS and temporal samples count. So you have to do some test renders to find the sweet spot for them to get the best possible motion blur. Next is the steering noise. When you add some drift, you can add extra movement with this parameter so it looks like the biker is trying to maintain the drift line. It also adds movements to the rear burnout. The next two are brake locks. When the bike moves, the wheels rotate automatically, and you can lock the wheels using these toggles. The next category is the read-only. You can read the speed of the bike in kilometers per hour here. The real steering of the bike can be read here. Because when the steering is automatic on the path, this steering parameter does not work, and the real steering is shown here. But when the steering is custom, these two will be equal. The last section is vibrations. First of all, do not forget to increase this overall multiplier amount. This is 0 by default. We have vibrations for the body and the wheels. Each of these has an amount and a speed. I'll zero out the body vibrations so you can see how wheels vibrate. The amount of wheels vibrations is in centimeters. And let's change the speed. Now let's see the body vibrations. The amount is in degrees and it is applied to the body pitch. And let's change the speed of it. The multiplier affects the amounts of these vibrations to quickly increase or decrease the vibrations or turn them off. Now let's see what these two are. When this user-defined time is off, the vibrations are continuously running on game time. Since these vibrations are per-lin noises, depending on the starting frame of your render, they might lead to different results each time you render. If you want to have the same frames each time you render, for example when you want to render multiple passes and composite them in another software, or if you want to cancel your render and resume rendering the remaining frames later, you need to make these vibrations non-random. If I turn on this user-defined time, my vibrations will stop. That's because this time parameter is our time now, and currently it is frozen at 0. If I keyframe it and increase it, the vibrations will run again. But to prevent faster or slower vibrations, it needs to be calculated in the correct seconds. So, this is what we do. First, we will turn this user-defined time off and set our vibrations, or maybe keyframe the vibrations in our sequence if we want. Because it is easier to visualize them when they are continuously running. When we're done with all the vibrations, then we will turn this on and set the first keyframe at the first frame to 0. Then we will go to the last frame in the sequence and calculate the overall seconds from the first frame to the last frame. By dividing the frame number by the FPS, we can find the overall seconds. In my case, it is 150 divided by 30, which results in 5. So, I'll set the time keyframe to 5 on the last frame. This way, your keyframe time works exactly like the game time. But now, all the vibrations are non-random. When I go back and forth between 2 frames, you can see the vibrations are repeating. This user-defined time also affects the steering noise and makes that non-random too. That's it for this video. I am looking forward to seeing your amazing creations with this system. See you later.